we're talking about solving systems of linear equations without graphing. So we're no longer graphing these lines that are going to meet in the middle. Although we can, it's not necessary all the time. Sometimes you don't have a graph. Sometimes they just give you equations and they want to go, okay, ready, figure this out. But right now we're going to look at number 1, and it says to consider the graph representing a systems of equations. Now last week when we were doing some of these problems, there was a spot where it didn't cross at an exact line, and everybody was like, it doesn't have a point. It does have a point, it's just not a whole number. So everybody look at number 1, and let's find where they meet in the middle. Can you put a dot on where they meet? Go. Okay, now we're going to estimate the coordinates. So I want you all to kind of guesstimate about how much or how, where, guesstimate. So like see where it could possibly be meeting. Are you laughing at my word? Guesstimate, guesstimate, guesstimate. It's like guessing and estimating at the same time. Guesstimate. Right, yeah. Okay, so somebody give me their guesstimate. What you got, Leah? She said 1.5, comma what? 3. Y'all agree? Anybody have anything different? What you got, Cooper? 1.6 repeating. And what? And 3. Okay. Now, we're going to determine whether or not these are solutions to our system. Now, we know how to do this. So let's look at the name of the equations. Ready? So you have y equals 3, and you have y equals 7 times x minus 8. What do we know how to do when we're given a coordinate point? Plug it in. We're substituting it in. So what goes where the y is? At 3. So does 3 equal 3? Yes. Okay, over here. Let's go ahead. Oh, guys, tell me you cannot see. Okay, what goes here? What goes at this y? 3. Let's try Leah's, just for grins and giggles, and see what happens. So what's going to go where the x is? Okay, who agrees with Joelle and Marley? Yeah, okay, cool. They said 1.5, so we're going to stick a 1.5 right there where the x is. And now we're going to do some math. Okay? So, you may use your calculators at this point. Here we go. So, 7 times 1.5 equals 10.5. So now you have 3 equals 10.5 minus 8. What's 10.5 minus 8? Does 3 equal 2.5? No. So guess what? That x value isn't quite right. But it's really hard to tell. So like if we look at this, that's really hard to tell. Let me zoom in a little bit. It looks about 1.5, does it not? It could possibly be 1.6. We could plug it in and see if it would work. So let's try it. 7, whew, that's really close. 7 times 1.66 equals 11.62 minus 8. Ooh, close, but that's almost even what? That's too much. That's too much. So our answer is going to be somewhere in the middle of there. It's too big, too small if it's 1.5. It's too big if it's 1.6 repeating. So our answer is going to be somewhere in the middle of there. But let's go ahead and turn to the next page. We're going to complete the 2 problems in the chart, and they want us to graph the systems of equations and estimate the solution. Okay, so let's go ahead and start graphing. How do I start graphing this, Amelie? What should I do first for the first problem? Start at 2. Yep. Over 1. It's going to go to the right because remember it's negative. Down 1, 2, 3, over right. And here is our first line. Everybody should be graphing with me. The goal is accuracy, because if you aren't accurate, you're gonna have some, like Miss Gode just did, have a really ugly looking line. That's okay though. And then how do I graph my next one, Isabel?
From -8 goes to the +8 and then go.
Just go across. +8, just go across. Like that? Okay. So now we have a point that's like somewhere right here. What do y'all estimate our solution could be? Let's see if we can figure out an estimation. Well, it's kind of, it can't be -2,8 because it's crossing at a different spot. Unless it's just my line. Hold on, let me just check my line. It could just be my line. Yeah, it's not quite -2 though. Do y'all see that? It's not quite -2. A little bit past it. So what would that look like as a number? If it's a little bit past -2. What y'all got? What you think, Braxton? If it's a little bit past 2 on this side, what number could we put as the x value? Pick a number. Good job. -2.2. We're going to estimate -2.2. And then what's our y value going to be, guys? 8. It has to be 8. Why? Because that's the only 8 there is. Okay, now we're going to check it. Same way we just checked it a second ago. We're going to plug that back into it. So 8 equals -3 times -2.2 plus 2, and 8 equals 8. We know that this one's correct. Let's check our work. So we have -3 times -2.2. What do we get? $6.6? What's 6.6 plus 2? 8.6. Are we super close? Does 8 almost equal 8.6? Are we close? Yes. Are we quite there yet? No. So now we're going to look at this, problem B. And we're going to actually solve this equation for x, okay? Because we want to know what the value of x is. So we know that our slope is -3. We know that our y-intercept is 2, and we know that this is our y equals 8. We know that our y equals 8, but we do not know what our x is. So we're going to solve this equation exactly the way that we would solve it if we were solving for the value of x. So how do I start solving this? Christopher, what's my first step? Christopher, how do I start solving this? Multiply everything by 8. Who agrees with Christopher? Who disagrees with Christopher? Okay. Cooper, what should be my first step? Subtract 2 from both sides. Like this? Like that? Class, y'all agree? Okay. So if we do that, we get 6 equals -3 times the value of x. Now what do I need to do? Divide. Who agrees with Joel? Divide by -3. 6 divided by -3 is -2 equals x. Okay, so what is our actual solution now? -2 comma 8. Let's check it. Ready? 8 equals -3 times -2 plus 2. 8 equals 6 plus 2. 8 equals 8. True or false? What's wrong? Well, we're proving it. So this one doesn't look like it's on 2. It looks like it's off a little bit. But you can prove, even if it's not on or off, you can prove it algebraically. And so the whole goal right now is to solve the system of equations algebraically, not necessarily graphically. So we've been doing it with a graph. I'm teaching you how to do it with the algebra. That's all we're doing. We're plugging and playing, okay? So here we go. Number 3. Consider the equation, the system of equations from problem 1. This is the one that we did on the first page. They want us to write an equation in one variable to represent the system of equation. What's one variable? Y or X. Okay, so Y or X. So we're going to use the system of equations to figure out how to write it in one variable. Now I have a question for you. Writing it in one variable means that we're going to take the information that we know to solve for what we don't know. So looking at these two things, what do you notice? What do y'all notice? Yes, ma'am. They're both y equals. That's a good observation. Okay. So are they both y equals big ol' conversations? Like big ol' equations? No. One of them has 7x minus 8. The other one has what? 3. So if y equals 7x minus 8 and y equals 3, what could you possibly do to start solving this problem? Substitute how? So Joelle's saying put the 3 where this y is. Would y'all agree or disagree? Okay, the reason why is because if I have 100 pennies and I have $1, do they look the same? Yes or no? No. Are they still equal? Yes. So where there's a y, we can substitute into another y. So if this whole y equals 3, that means that I can put 3 where this y is, because you make y equal y. Does that make sense? Because the value of y equals y, correct? Yes. So ready? 3 equals 7x minus 8. Could you solve for x now? Could you figure out what the value of x is? Go ahead. Okay, so we're going to do a think, pair, share real quick. So now that you've spent time looking at it, I want you to turn to your neighbor and I want you to talk about this, the strategy that you use to solve this. Ready? Go. Okay, so what was our solution? What was our solution? So, Jordan says 11 over 7. Is that the solution though? Because they want the system of the what? Equation. So that means that our system of equation is going to have a what as a solution? A what? A coordinate point. So what do we have to have as our y value? 3. What do we have to have as our x coordinate? Hold on. What's our x coordinate? I'm sorry. Yeah. My bad. Got it. 11/7 is our x. Sorry, guys. I transpose things all the time. Make mistakes. So, we need to write it as a coordinate point. Let's check our work. So, you should have gotten 11/7. Add 8, 11 equals 7x. Divide by 7, divide by 7. 11/7 equals x. And then we know that this is now the system of the solutions because it is the answer for both. This is where they're both going to meet. Okay, ready? Let's look at number 4. What you're going to do is you're going to do number 4 and 5 as a partner. Okay? 4 and 5 as a partner group. Y'all are going to work on it together. I'm going to give you about 3 minutes, so 1.5 minutes for each question. Okay? Ready? Go. Okay, let's look at the first one. The first one says that we have y equals x minus 10 and y equals 3x. So if y equals this and y equals this, that means that both of them should equal each other. So you can set up the system of equations just like this. 3x equals x plus 10. Now, what we're going to do is we're going to solve for the value of x. So we have to, just like we were solving two-step equations, subtract x from both sides. 2 times x equals 10. 2 times what number equals 10? 5. So divide by 2. Divide by 2, x equals 5. Am I done with my problem? No, I now have to figure out what the value of x is. That means that I can substitute into either equation, the first one or the second one. So ready? That means that I can do y equals 5 plus 10 or y equals 3 times 5. Guess what I'm going to get for my y either way? 15. All I did was substitute the value of x back into the equations, and that gave me the value for y. So the solution is 5, 15. This is the solution to my system of equations. Any questions on how I got those? Okay, let's look at the next one. Same situation here. I heard some people saying I need to put it in slope-intercept form. I need to rearrange it. I need to do all of these things. But the whole purpose of this is that we're plugging in what we know to what we don't know. All we're going to do is where there is a y, we are going to substitute. Ready? 1/2 x minus 12 equals 2x minus 3. Now we're solving a multi-step equation with variables on both sides. Same variable. So that means that we need to get like terms alike. The way you do this is you can use the box method, or you can be able to solve it however you feel necessary. I'm going to go ahead and just do math. I'm going to add 3 to both sides. So now I have 1/2 times x. What's negative 12 plus 3? Anybody? Negative 9. Now I'm going to subtract 1/2 x. Negative 9 equals 1 and 1/2 x. You take a half away from 2, you get 1.5. Yes? Okay. Now, fun story, when you don't know how to multiply or divide by the fractions, guess what you can use? Handy dandy calculators. Woo-hoo! Okay, here we go. So, negative 9 divided by, I'm going to go ahead and just do 1.5. And I get negative 6 equals my x. Now I can take the value of x and do what with it, guys? substitute it back into my equation. Which one y'all want? The first one or the second one? It doesn't matter which one you use. Y equals 2 times negative 6 minus 3. What's 2 times negative 6? Minus 3. So my solution to my system of equations is negative 6 comma negative 15. How are we? We okay? Okay, so what I want you to do is with your groups, I'm going to give you 2 minutes per problem. So I'm going to give you 8 minutes. And I want you to do number 6 through 9. 6 through 9. 2 minutes per problem, okay? So, go. That 3x equaled 3y minus 6 and 3x equaled 2y. Well, if 3x equals this and 3x equals this, then that means that 3y minus 6 must equal 2y. Has to. They're the same thing. So 3y minus 6 equals 2y, and I solved for the value of y, and then I took the value of y and I plugged it in to solve for the value of x. That gave me 4 comma 6 as my answer. Use logic to solve. Don't make it harder on yourself by putting it in slope-intercept form. You could have done this, divide everything by 2, and then you would have gotten 3 over 2 times x equals y, but then you would have been plugging in a bunch of fractions. It's totally up to you, however, which way you want to do it. If you want to work with a bunch of fractions, have fun with that. I don't want to work with a bunch of fractions. That's a hot mess. Make it easier on yourself. Okay, everybody look at number 7. Number 7, we are, oh, by the way, this one only had one solution. Let's look at this problem. Oh, that looks like fun. I'm going to go ahead and subtract 2. So y equals 2x plus 1. I just reconverted this one. I subtracted 2 from both sides. And now I could do the same thing on here. I could just move 2 from this side. Subtract 2, y equals 4x minus 2. They have a different slope, different y-intercept, so most likely they're going to have one solution. 2x plus 1 equals 4x minus 2. Subtract 2x. Add 2. So cancels out. 3 equals 2x. Cancels out. Divide by 2. X equals 3 over 2. Now I could go back in and plug that all in. But I'm just going to pick an equation. Do y'all want the first equation or the second equation? First one. Okay, here we go. Y equals 2 times 3 over 2 plus 1. What's 2 times 3? 6. What's 6 divided by 2? 3. One solution. All we're doing is substituting. That's it. We're taking the information that we know and we're plugging it into what we don't know. That's all we're doing is substituting our information. Okay, let's look at the next one. Oh no, there's fractions. What am I gonna do? What's an opportunity that I could do? God bless you.
No solution.
Why?
Because the variables are the same, but the constants are not.
Variables are the same, but the constants are not.
Right, because you're like doing 5y minus 1, it does not equal 5y plus 2.
Okay, so Joel said that 5y minus 1 does not equal 5y plus 2, and this are exactly the same. So because they do not have anything that is the same on this end, then that means that it is no solution. The reason being is because 2 plus 5y equals 5y minus 1. Can you have 5y plus 2 equal 5y minus 1? No, it will be no solution because 2 does not equal negative 1. And last but not least, my paper's printed all redonkulous. Okay, so what we're going to do is if 2x equals this and 2x equals this, that means that this has to equal this. So 5 times negative 2 is negative 10, plus 5 times 3y is 15y equals 15y minus 10. What do you know? What do you know?
What do I know?
That if we kept doing this problem, what would happen?
They're the same. Infinite many solutions.
Infinite solutions. Okay, go ahead and turn to page 85. Turn to page 85. Now we're going to use a visual because sometimes we need a visual. Yes?
I think get number 6.
What do you mean didn't get?
Can I see it?
Okay, so now we're going to look at our tape diagram on page 85. Everybody on page 85? Okay, so we are now looking at our tape diagram. What you'll notice about, I want you to go ahead and solve number 1 and 2 really quickly. I'm going to give you about 2 minutes. 1 and 2. Just look at it. Y'all might be able to figure it out. 1 and 2. What did you find for number 1? What did y'all figure out the value of x was? X equals 7. And what was the value of y? More Atlanta. Guys, if the value of x was what? 7, and this is the same x value, so how much does this x value equal? 7. And if you have 7 and 5, what do you get? You get the value of y, which is 12. We're adding. You're just adding. Look at it. If this, it's like a puzzle, guys. If you have this block is 7, and the same block is here, and this block is worth 5, 7 plus 5 is 12. So what we're doing, huh? Because they multiplied. We're not multiplying, we're adding. Okay, ready? Christopher, please don't. Okay, ready? Hold on. Let's figure out this one. So, what do you know about x and y? X plus y is what? 10. X plus y equals 10. What do you know here? Y equals x plus 2. So, what can we do with this information? We could. How do we solve it? Okay, guys, ready? If the value of x added to y equals 10, and you know the value of y, what could you do with the value of y? plug it into where there's a y. So that means that this right here gets to live right here. They're the same thing. They have the same value. So x plus 2 equals 10. 2x plus 2 equals 10 minus 2. 2x equals 8. Divide by 2. X equals 4. So if the value of x is 4, what do we know now? Y equals 4 plus 2, so y has to equal what, class? Why are we making weird faces at Miss Dode? I'm doing math that we've been doing since about 3 months ago. Combining like terms, making sure that we're solving for a variable. We find that one variable, we can use it to find the other variable. This is where you are learning to find and solve a puzzle. This is puzzle math. This is why Mrs. Dode likes it so much, is because I'm able to see, okay, ready? Here we go. If this plus this equals this, and this equals this, then that means that this has to go here. You're learning how to fix and move things around. Turn the page. Okay, so let's look at problem 3. I'm going to show you how to do something. I'm only going to show you how to do it once because you need to learn how to do it either way. But we are going to split our paper in half. So I want you to just draw a line down the smack dab of the middle of your paper. It doesn't have to be straight. One side we're going to solve for the value of x, the other one we're going to solve for the value of y. You need to write these notes. You have two equations. You have x plus y equals 10 and y equals x plus 2. So if we're going to solve for x, that means we're going to try to get all of our x's to be, we're going to try to get the value of x first. The other one we're going to solve for y. So we're going to do the exact same thing, but we are going to solve for the value of y instead of the value of x. In this case, we know that we can take this value of y and plug it here. That means that everything that's attached to it gets to go where that y is. So x plus 2 equals 10. This is exactly the same problem we just did on the flip side. So combine like terms. X and x is 2 x's plus 2 equals 10. From there, what's my step? Subtract what? 2. Subtract 2 from both sides. 2 times x equals 8. Now what do? Divide by 2, divide by 2, x equals 4. I can then take that information and plug it into an equation. Which one do y'all want, the first equation or the second one? Second, y equals 4 plus 2, y equals 6. So my system is 4, 6. That's my solution. Let's go and solve for the value of y on the right side. Pay attention. So if the value of y, we know that this is here, but that means we have to plug in for x. So I have to subtract y from this side. X equals negative y plus 10. So that means that we need to plug in for x. So x equals all of this stuff. Y equals negative y plus 10 plus 2. Y equals negative y plus 12. Add y to y equals 12. Divide by 2, y equals 6. take this information and you can plug it into to solve for x. 6 equals x plus 2 minus 2 minus 2. 4 equals x. Again, 4 comma 6. This one was harder than this one. I picked the one that's the easiest to isolate. Okay, look at number 4. We're applying properties of equality to write your equation correctly. So as we keep working through problems, we're trying to figure out what is the best way to solve this. Can you solve for x or can you solve for y? So I want everybody to look at number 4, please. Number 4 says, find an expression equivalent to x. Then solve, so we want to find an equivalent expression to x. Then solve the system of equations by using the substitution method. Check your answer. So we want to solve for what? X or y? What are they telling us to solve for? We're finding the equivalent to what? X. And then we're going to solve. So in order to solve for x, we need to take our equation, x plus 2y equals 2, and we need to set it equal to what? What's it tell us to? X. We need to set it equal to x. We need to know x by itself. So how do we get x by itself? Subtract what? 2y. So x equals negative 2y plus 2. Now we have another equation that says 5 times the value of x plus y equals 10. So we're going to take the information that we solved here and put it where? Where the x is. Right there. So it's going to look like this. 5, this is multiplication, times negative 2 times y plus 2 plus y equals 10. So all Miss Goday did was take all that information and plug it right where the x is. Now I'm going to use what? The distributive property. It's a lot of 10s. I'm at the point that, like, where I don't need to, do I need to show y'all how to go 5 times negative 2y? 5 times 2. I think we should be okay. Are we okay with that? Okay, so negative 10y plus 10 plus y, we need to combine like terms. What's like terms? The what? The y's. Negative 10y plus y is negative 9y plus 10 equals 10. Now we're going to solve for the value of y. So we're going to subtract 10. Then we're going to divide by, negative 9. Okay, so y equals, what's 0 divided by negative 9? 0. So the value of y is 0. What do I do with 0 now that I have a 0? We have to take it all and do what? Plug it back in. Substitute it back in for what variable? We need to now solve for what? We already solved for y. We need to solve for what? X. We need to solve for the value of x. So what equation do y'all want to use? The first or the second one? This right here? So I'm substituting the value into your equation. So what's negative 2 times 0? What's 0 plus 2? 2, so the value of x equals? So what's my solution? 2 comma 0 is the solution to my equation. Now let's look at the next one. We're solving now for y. Same situation, but now instead of doing x, we're doing the y's. So now we want to get y by itself. So here you go, 5x plus y equals 10. Subtract 5x. Y equals negative 5x plus 10. I'm going to take my other equation, x plus 2y equals 2. And where there is a y, I'm going to substitute all of this information. X plus 2 times negative 5x plus 10. Guess what we're doing? The exact same problem, but we're using it to solve for the y's. Again, we're going to multiply it out. X plus negative 10 times x plus 10 equals 2. Combine like terms. Negative 9x plus 10 equals 2. Subtract 10 from both sides. Negative 9x equals 2 minus 10. I did math wrong. Where? I didn't multiply 10. Thank you. 20, 20, 20, 20. Negative 18. Divide by negative 9. X equals 2. Isn't that the same number we got on the flip side? Look at the problem before it. Did we get x equals 2? Don't just copy what I'm writing. Understand what I'm doing. Is that what we got on the flip side? Okay, so now we're going to take the value of x minus 2. Which equation do you want, first or second? Two plus 2 times y equals 2. Minus 2. Y equals 0. I want everybody to do number 6, please. Number 6. I'm going to give you 3 minutes to work with your groups.